Hello and welcome to this video on simple harmonic motion. Today we're specifically talking about taking our information about simple harmonic motion and applying it to AP style problems. The AP exam likes giving graphs or calculations and not directly asking you about your knowledge, but asking you to apply it, making understanding of it. So we have 7 sample problems all based on this same graph and the same base setup. A simple pendulum was constructed and the graph of its velocity as a function of time is given above. Given the graph is going to be the basis for every question we deal. After that, things might fluctuate a bit, but that is the basics. And we're going to take a look at how this information can change, how the understanding can change as we go on.
For each question, I'll introduce it, then pause so you have a chance to think, and then you can come back and check your answer.
We'll start with a fairly simple one. What is the period of this pendulum? As a reminder, the period is a full repetition. It's going to go through one full cycle. This doesn't complete the cycle. There are several ways you can go about finding this. You can go, well, it is 1 second from 0 to a crest. So at that point, it would be 4 seconds to do 4 full cycles of that. 1, 2, 3, 4. You can visualize and go, well, this is in 3 seconds we've gone through 3/4 of a wave, so 4 seconds will get us all the way there. But the simplest and most common way I typically do it is I go, well, I have half of a bump here. 0 back is 1/2 of it. Half happens in 2 seconds, so if 1/2 equals 2 sec, multiply both sides by 2, a full equals 4 sec. So my period would be 4 seconds. Regardless of how you go about it, just the information here is your ability to read a graph and interpret it. It's asking what is the length of the pendulum? Well, we don't have anything about the length here. We don't even have any real information, but what we do know is that we can find the period. Period of a pendulum is 2 pi square root of L
over G.
And once I find that period, finding G is just a matter of plugging in and solving. In this case, we've already said the period is 4 seconds, so it's 2 pi L over G. Rearrange, I get 2 over pi equals the square root of L over G, or 4 over pi squared equals L over G, which means L is 4G over pi, which is an exact answer, which is typically what you'll see on the AP exam, but a more numerical value, graph squared, 3.97 meters. This is more emblematic than the previous question is of AP style questions, is it requires you to apply your knowledge and go an extra step. It's very rarely the one step, it's deeper applications. Let's keep going. The simple pendulum was constructed above. Given the above graph and the mass of the pendulum bomb, how could you find the maximum potential? This one changes it, and instead of going through and asking you to calculate or make any measurements, it's discussing and applying your logic. It's asking you to find the maximum potential energy. We don't have anything directly relating to potential energy, but we do know that for a pendulum, that the maximum potential energy will be here when your velocity is 0. And furthermore, we know that the energy constantly transfers from EK to EG, back to EK, back to EG, and cycles through it, and the energy is conserved. So whatever energy you have here, you can go through the process and be like, well, the amount of energy that I have at the highest velocity point, which would be the point where the EK is at its max, would then equal the amount of potential energy I have because the energy is conserved and transferred. So by multiplying 1/2 times the mass times the -1 I have here squared, that would equal my maximum kinetic energy, which would also equal my maximum potential energy. Or in other words, your maximum potential energy in this case is going to be m over 2. And there you have it, whatever the mass is. The idea here is to apply what you know and relate it. We know the energy is conserved, so by finding one point, we can find the other. This one asks us to draw an approximation of the position time graph for the same time interval. We don't know where exactly or how tall the amplitude is. All we know is that the velocity is 0 here, -1 here, 0 here, 1. What I like to do with this is draw it right on top of it to give me a rough shape and then copy it over later. But the idea here would be that any point where my velocity is 0, my amplitude would be the greatest. So I would have a max or min. And further, I know for a fact that when I'm at my positive extreme, only place I can move is negative. So my negative velocity would start there. I would have to have negative velocity to move back from that. To put it a different way, if I'm at 5 and that's my maximum value, and next I'm at 4, I've made a negative movement. I'm having negative movement, so I have to be moving down from my maximum value. Whenever my velocity is at its max, my position has to be 0. And then from there, it is just a matter of finishing out the curve and getting you something like this, but better drawn. If you want to instead, you can do it over here. Just mark out your 1, 2, 3, and 4 seconds. And, be better at drawing than I am. Again, the idea here is to take what you know and apply it, not necessarily directly do calculations. A simple pendulum is constructed in the graph of its velocity as a function of time is given above. Given the graph above, predict how fast the pendulum is going at 10 seconds. For this, it requires you to notice pattern, make recognitions. And if you look, this is a periodic pattern. It will continue repeating. At 4 seconds, it will be back at 0. And from here, we can start extrapolating things. We'll notice that every even number, in this case, it's at 0. And if it was 1, and then 4 seconds later, 5 seconds, it would be a -1. But the pattern is, we'll continue repeating. For our purposes in this case, 10 seconds is an even number, and every even number will have a velocity of 0. So my velocity prediction would be 0. Simple pendulum is constructed in the graph is given above. Given the expression above, if the pendulum broke at t equals 8 seconds, derive an expression for how long it takes for the bob to strike the ground. Okay, this is the exact same question as above, plus, because it doesn't ask you to find the velocity at 8, but it does require you to do so. And again, we said it's an even number, so it's going to be at 0, so my v initial would be 0. Delta y, or my falling height, or delta h if you'd prefer, equals v naught t plus 1/2 at squared, is an expression that would let me find it because it's in free fall. I know my velocity initial is 0, so this term cancels out. My acceleration is going to be g, and I just need to find my height. If I were to rearrange this and solve, I'd get t equals 2 times h over g in the square root. And that would give me an expression for how long it takes to fall down to the ground. It would be the height it is above the ground at the moment it breaks, times 2 divided by g, gives me an approximate amount of time. The big trick here is not the solving, the rearranging. That's fairly easy. The trick here is recognizing what your initial velocity is, and that's information you could get. Again, a lot of the potential information is hidden behind expectations. Final one, a simple pendulum is constructed in the graph of velocity is function of time given above. Given the above graph and knowing the mass of the bob is 0.25 kilograms, calculate the gravitational potential energy at 2 seconds. This harkens back to a previous question where I was like, how would you calculate the maximum potential energy? At 2 seconds, my velocity is 0, which tells me that my potential energy is at its max. So if I can find my kinetic energy at the maximum point here, that'll be equal to the potential energy here because the energy has to be conserved. So looking here, 1/2 mv squared, 1/2 times 0.25 times -1 squared gives me 1/2 times 0.25, which is 1/8 or 0.125 joules. I could also do this for any other point. Find the potential energy here, and then it would be the difference in my kinetic energies would be the potential energy. gained. But I chose an easy one to kind of ease you into this and go for quickly. But anyways, this is 7 AP style questions, all involving this graph and in harmonic motion. Thanks for watching. Have a good one.